Hey guys, this is Snowy, and welcome to a second test of the City Skylines page file dilemma. Now, in the previous video, you saw me doing a test with the City Skylines, how fast it would boot, whether you have a page file of 2 GB or 128 GB. Now, at that time, there was no difference because my system already contained 64 GB of RAM. So my assumption is that the system already took advantage of that RAM and did not even touch the page file. But I'm not sure about that because the startup times in both cases were like both 1 minute and 43 seconds. What I'm going to do now is without removing actually a DIMM from my computer because I don't want to, I'm going to boot up with a page file of 128 GB. Yeah, okay, and remove this. And I also installed data RAM disk. Now, I created a RAM disk of 48 GB. That means that if you go to Task Manager and you look at memory, that there is now only 13.6 GB available. Now what I'm going to do now is, I am sure that the map that I'm currently playing, which is called Bust Down, is using more than 13.6 GB. So now I will start the game and I will measure the load time. Then I will reinstall data RAM. It's sad, reinstall it. Then decrease this value to, let's say, 32 or maybe less, so I have more memory available, like, I don't know, something that would make this like around 30, let's say 16 GB more, and to see if there is any difference. So I will leave these tabs here, and we will see if we click City Skylines, and let's see how much time it now takes for the game to boot. Now let's wait until it opens. Okay, I click on play. I don't click on resume because I want to start the timer. At the moment I click the button. So you have seen the system now has like roughly 13.6 GB of RAM available and a page file of 128 GB. And we will see whether, if we add some RAM more later, if there would be any noticeable difference. Okay, we click on load game. Click. Bust Down, this is my current city which I'm playing. And I click on, at the moment I click on load, I will start a timer. So, 3, 2, 1, go. Also, what we are going to look at is the amount of frames per second, if that is affected by the amount of virtual memory. So the game will now be starting any moment. So as soon as I see the screen, it is in pause mode, then I will stop the timer. And I cannot say anything about it yet because I have to record the other version as well with some memory more than I have now. So let's see what happens. Yeah, it's obvious it is pumping more stuff in the virtual memory. It takes already longer than usual. It might crash, I don't know. I have no idea. Well, it takes a lot of time. So this is theoretically with a system of... here we go. Okay, so that is the loading of the game now. I will stop now the video and I will be right back, and then we will do this again. Okay, what I also did, I forgot to load Bandicam, so to show the FPS counter in the upper right corner, I reloaded the game under the same circumstances, like with only 13 point somewhat gigabytes of RAM and 128 gigabytes of page file. And I press the space bar now, like that. And let's check what we see on FPS. So we see like 18. So it will differ a little bit. I specifically chose for this spot because there are a lot of people coming from the space elevator. So they walk in front of you. The game is running on normal speed. It does like 16, 17, 18, 18, 18, 17, 18. Yeah, it depends also a little bit on how many ships are traveling by. I don't know, maybe we should find a spot that is more like, I don't know, showing the same kind of dynamic. I'm not sure. Maybe looking the city from, completely from here, from above, from all the corner, like this. This is just the entire city. Okay, so these are two places to remember. One, watching out at the space elevator. We saw like an average of like 18 frames per second. We are now watching the city all the way from the left south corner, sort of. And it does average, 27, 28, 29. Okay, so let's keep that in mind. We know, at this moment I do not know the startup time because I still have to put that into the video. And later I will draw my conclusions based on these tests. Okay, I will end the game now and I will switch the RAM disk to a lower value so more system memory is available. And let's see if we see any difference at all. So I will be right back. Okay, I'm back again. I restarted the computer and I reset the data RAM disk to create a RAM disk of 32 gigabytes. And now we have a little bit more gigabytes available. So the question now is like, how much time will City Skylines use to load, with a little bit more normal RAM and with the same amount of page file, 128 gigabytes, and see if there is any difference whatsoever. I also need to restart later again with Bandicam to measure also the FPS, but I cannot do it right now because if I put Bandicam in the background, it will influence the startup time, so I have to do it twice, sadly enough. Okay, here we go. City Skylines. Okay, now let's wait. We click on play. Like I said, I will put a timer in there in the video when I make it in the video editor. And after I done that, I will draw my conclusions. Or I make another video with my normal settings, yes, where I do not use a big page file, only 2 gigabytes, but have a much smaller RAM disk, of only 4 gigabytes, so I have most of my normal RAM available. So let's try this again, bust down, and we say like at the moment that I click load, the timer will start. So 3, 2, 1, start. And here we wait again. Yeah. I think it will be faster because I saw that at the end the system was struggling because it ran out of normal memory. It could not put any more assets into normal memory, so it had to write it into the virtual memory, which is of course slower. So in theory the game should load now faster because it has 16 gigabytes extra. But what I'm curious also of is like if later, if I have restarted it again to see if there's also a difference in frame rate, also that, and then I will restart my computer to the former situation with a RAM disk of only 4 gigabytes because that is my standard RAM disk, and see whether then there is a difference, and also with a with a much smaller page file. What I found odd on my regular system is that the upper value shows the amount of memory it takes, and the lower value is the virtual memory. But even when virtual memory is set to 2 gigabytes, it still says like, okay, we are using 30 gigabytes. Huh? Yeah, I don't know. So let's see how long this will take. I don't know. I think it's faster. I think. Yeah, the last piece will always take a while. We get these nice Chinese signs on the left, Ding dong. Yeah, okay, so we have it. This is also the place actually where I saved the game before I restarted it. So now at this point, when I restart it again, I can press the spacebar and count the FPS. In the previous setting, the FPS was around 18, 17, 18, sometimes 19. So what I will do now, I will restart this thing, but then with Bandicam in the background, and we can then see the counter. So okay, we'll be right back. Okay, so I reloaded the game, this time with Bandicam on the background, and let's press the spacebar. Let's have a look at the frames per second tab. Well, it shows roughly the same thing, 18, 19, 18. I wonder if you guys can even read that little thing, all here, here in the corner, that little green thing there. But I can say what it says. It says like 18, 19. Actually, it does not make any much difference, this. And I think I know why. Because the amount of frames per second is not so much dependent on the amount of RAM, but it's dependent on your CPU. I mean, probably my video card is doing not much right now, because let's face it, the most stuff you see is static on your screen, non-motionless. I mean, if you compare this with a game like Battlefield, for example, Battlefield 5 or something, that's way more dynamic than this is. This is pretty static. It's a simulation, so everything falls down to the CPU, and that's why it's generating the same amount of FPS. Now let's get to the upper corner, like we did before, of the map. Oh, where are we? Here. And this gave us last time, was it roughly like this? Yeah, like this. So what do we see now? We see here again a frame rate of like, 27, 28. Yeah, that's roughly the same. So yes, it's clear by now that the amount of RAM you have is not really of influence of your frame rate. The frame rate is mostly determined by your CPU, not even by your GPU. I mean, if you have a fast video card, it will probably sleeping while you are playing this game, while your CPU is sweating like an idiot. because it is a simulation. This game is a simulation, and the thing that you are seeing on screen is just a graphical presentation of it. So okay, so that is clear. Yeah, we're going to reboot this game now under my own settings with all my memory and with a lower page file, because I don't think I need a big page file when I have 64 gigabytes of memory. Now the reason why I have to do that with this map is because the previous test I did was with another map, so I cannot compare that amount of loading time with the loading times I had now, so I have to do it with this map now. Yes, so we will do that in a moment, so be right back. Okay guys, here we are back again in the original settings, how I normally play City Skylines, with just a RAM disk of 4 gigabytes and a page file of only 2 gigabytes, as you see here on the screen. So, according to my task manager, I have 56.5 gigabytes available. So let's see what the startup time of City Skylines will be now in this situation. Now let's start it. Here we go again. Play. Yeah. Colossal order. Please bring us, City Skylines Part 2, with optimized processor support, so it can support up to like 50 processors or whatever. Okay, load game, bust down. Here we are again. Okay, we start a counter at 3, 2, 1, go. Now I was also thinking, when I was doing the loading times, with the very small amount of memory I had and the very large RAM disk, I was thinking what would have happened if I had put the page file into the RAM disk. That sounds like interesting. It's like also sounds a little bit contradicting, actually, putting the page file into the RAM disk, because a page file is used when you are out of RAM, and then you are putting a page file into a RAM disk. It's like, okay. But it would make that page file pretty fast if you put it inside a RAM disk. A RAM disk is bloody fast. It's really fast. Okay, the timer is running. Even at this moment I have no idea, so we will see if there is any difference now. So in principle I would say it would stuff more assets now in regular memory than in a virtual memory, because when in the first setting, this one upper value stuck already at 12 gigabytes or something, so it can put more things now in regular memory, which would be faster. But yeah, it cannot go faster than the storage media device can deliver, which is just a Samsung Evo SATA SSD of 1 terabyte. So we will see how much time this will take. Now, after that we draw conclusions, I hope. Okay, so it's here. Okay, so I think that I have now all the recordings I need. I am going to put all this stuff now in the video editor. And yeah, with a timer to it, and after I've done that, I will make a comment that I will also put in the video itself. So it would be sort of like making, while I'm making the video, this video in the video editor, I will also, create a video to put later into the video editor. It's very weird, and you see me already busy on the video editor. So, okay. Well, we'll be right back, and we'll see the end results. So, hey guys, here I am, back again, and you see the video editor in the background, and the results are in. The first video, the first capture I did took 2 minutes and 30 seconds to load, and the frame rates were respectively 18 on the space elevator, roughly 18 FPS, and from the air, or looking from above, it was about 28, 29 something. Now the second load, when we had extra memory, we had like 32 gigabytes of memory sort of available. The load time was 2 minutes and 16 seconds. And to no surprise, the frame rate was exactly the same. Like already explained in the video, the frame rate is not so much determined by the amount of memory, but more by the speed of your CPU, because that's the item that is actually doing the job, and your RAM does do nothing, and also your graphics card is doing not that much at all. Now, to my surprise, when I loaded the game into the normal settings I use with the full 64 gigabytes capacity, the loading times were 2 minutes and 15 seconds, so just slightly 1 second less than the previous load. I might, with the timer I put in the video, as you can see, it's still in the editor, I might have put the timer maybe just after I said the word load. I don't know, maybe there is like half a second difference. I think personally that in the second video there was enough RAM already to load all the assets and the mods into RAM. So whether you had a page file of 2 gigabytes or 128, I think it did not matter, because there was already enough RAM available. And that also explains why in my current settings, the last one that you just saw, that the load time was actually the same. So yeah, the game at this moment with this map does not use more than 32 gigabytes, maybe 30 at best. So end conclusion is like, yeah, more memory is better. It loads faster because it has to load less stuff into the virtual memory. And yeah, my conclusion would be buy as much RAM as your motherboard can support. And regarding CPU, buy the fastest CPU you can get. And that's a tricky one, especially right now at this moment, because the choice between an Intel i9 and the latest AMD Ryzen X 3900, I'm not sure, is pretty difficult, because the Intel i9 is an 8-core processor, while the AMD is a 16-core processor, if I'm right about that. I did not check it, but the Intel processor is faster, but only has 8 cores. But the game itself, City Skylines, only uses 4-core maximum with 8 threads. So basically, if you have a faster core speed, let's say 8 cores, which are running at 5 gigahertz, which the latest model of Intel does, would theoretically make the game faster than the 16-core AMD, which runs at turbo boost, probably at 4.6 gigahertz. But anyway, that would save you up like 400 megahertz times 4 cores, which City Skylines is using. And it's a difference of 1.6 gigahertz, and yeah, okay, that will definitely be visible in the FPS counter and also the playability of this game. But here comes the but. We at current in July 2020 right now, we do not know if Colossal Order, hear me. If Colossal Order wants to build or create City Skylines 2, and I cannot blame them, because why would they even build City Skylines 2 if they can just add a new DLC and another one, and they can easily earn money with that by building a complete new game. City Skylines 2, they basically throw away all that easy money they can get by adding more stuff for City Skylines Part 1, sadly enough for us. Maybe in the future, I hope that they would do it. I hope that that maybe they will look at the engine of City Skylines, and maybe they give the engine an update so it will support more cores. That would be a real good thing for all those people who have like an 8 core, a 16 core, a 32, or even 64. I mean, even those cores are there. And since this game is so CPU heavily driven, I'm surprised that they did not do it so far yet. So yeah. So okay, guys, that's my end conclusion, and yeah, I hope to see you soon again in my city where I'm busy with Bosstown. That's also the example that I used so far, and I will see you. I'll see you then. So for now, happy playing, and build nice cities and show them off in the City Skylines group on Facebook, and yeah, I'll also be there under the name Snowy. So, okay, guys, see you.